Okay, so number 9, and then we'll go back to 1.2 after we talk about this guy. Right, so 1 over x minus 3 minus 1 over x plus 3 equals 6 over x squared minus 9. So the first thing you actually want to do is factor that right-hand side denominator, x squared minus 9. This is what we call as difference of squares. So if you want to think about that x squared minus 9, we can write that 9 as 3 times 3. Okay, hold on. Looks like my calibration, that's off. All right, so basically the idea is you're using difference of squares here to help you factor this. So I can rewrite that 9 as 3 squared, and the rule here that you're using is basically it's going to be x and 3, once with a plus sign, once with a minus sign. So if factoring is something you haven't done in a long time, then obviously that's something you want to review. Those of you who are in the lab will definitely be reviewing it in the lab, but those of you who are not, you definitely want to make sure you go back and kind of take a look at this. Because what happens is when you factor it, you will see it forms a combination of both of these other two denominators. So together, they're actually going to form our least common denominator. So you can rewrite this guy here as x plus 3, x minus 3. So our least common denominator is going to be a product for both of them. Okay? So now remember, the way I was showing you guys was, let's multiply the entire equation by that least common denominator so that we can get rid of our denominators and we don't have to worry about working with those fractions anymore. And Levi, that's kind of what happened with your example that you showed me. Since you only had one of these, you were not able to cancel out the other one, right? And some of you others also kind of did that same thing where you just used x plus 3 or x minus 3 as your denominator, and it didn't work out. So we're going to take both of these factors and multiply with each of our terms from the equation. So that's going to be the first term, x minus 3. Then we have a minus sign here. Multiplied with our second term, which was 1 over x plus 3. And then on the other side of our equal to sign, yeah, see, it seems to be not calibrating on this side for some reason. The denominator, I'm actually going to write it in the factor form so it'll become easy for us to cancel out. So instead of writing x squared minus 9, the denominator I'm going to write as x minus 3 and x plus 3. Okay? So after we multiply our least common denominator with each term, cancel out the common denominators that you can. So in the first one, only x minus 3 cancels out. Second one, only x plus 3 will cancel out. And of course, the third one, or the last one, is where both of these should cancel out. So since these first two terms only had one of our denominators, only one of those cancels out, right? The last one, x squared minus 9, since it factors into both the terms, both of them will cancel out, which means we'll only be left behind with the 6 on that right-hand side. On the left-hand side, I have x plus 3 times 1. So that'll become x plus 3. Obviously, my denominator is gone. I have a minus sign here. You got to be very, very careful when you have a minus sign. If it was a plus sign, it wouldn't make a difference, but minus sign does. So you still are doing x minus 3 multiplied by 1, which would be x minus 3. But this negative sign has to be distributed inside of our parentheses.
Minus x plus
Very good. Yeah, exactly. So when I distribute that, becomes negative x, negative times negative becomes positive 3. You know, Iram, it does look like your x is canceling out, doesn't it?
Yeah.
And then on the right-hand side, since everything canceled out, we just had that 6 left behind. Okay, if our x is canceling out, what do we get left behind with then? Yeah, exactly. So it looks like you were right. X does cancel out. Because now, you know, once you get down to this point, the idea is we combine like terms, which means we combine the x with the x term, the 3 with the other 3 term. So since it's positive x and negative x, they will end up canceling each other out. So your x does disappear. And then you are getting 3 plus 3, which is of course 6. So you actually end up getting 6 equals 6, which will make this, I don't, because you had inconsistent on your paper.
Yeah. That's not it.
So when you get a true statement, what did we say? Yeah, it's actually going to be an identity. And if it is an identity, then actually that means you can use any value for x, with the exception of those numbers that will make our denominator 0. Okay, so basically, as you can see, our x canceled out. We're getting 6 equals 6. Now, obviously, if you subtract 6 on both sides, you'll end up getting 0 equals 0, which still leads us to the same conclusion that this is an identity, which means we can use any value for x, except what numbers can we not use? What numbers are making our original denominators into a 0? What number can I put in here which will make this denominator into a 0? 3. And what number can I put in here which will make this denominator into 3? Yeah, negative 3. So positive 3 and negative 3 are two numbers we cannot use for our x because those two numbers make our denominator 0. Now think about this right-hand side. If I use positive 3, 3 squared still gives me 9, right? 9 minus 9 will be 0. If I use negative 3 for my x, negative 3 times negative 3 becomes positive 9. Positive 9 minus 9 will still end up giving me 0, right? So both positive 3 and negative 3 are going to make my denominator 0, which means my x cannot be those two numbers. So when you write your answer down, we'll basically say your solution can be all real numbers except positive 3 and negative 3. Or you can also write it as so it can be any x except x cannot be positive or negative.